Hi, physics. This is Mr. Janowski. This is Chapter 8, Homework 2, Problem 6. So we've got a volleyball. It's approaching you at that velocity, 3.8 meters per second. You bump it back in the opposite direction. So the fact that it's the opposite direction is going to be important at 2.40 meters per second. So if the ball is in contact with your arms for that amount of time, what is the average force you apply to it? So what we're looking for, if we were going to do a step huh for this, what are we looking for? We want the average force, or just the force. So we want force is equal to question mark newtons. All right, so what's going on here is we can figure out the initial momentum of the volleyball. So that's when it's approaching you. The final momentum, which is its momentum after you bump it back. So then we can figure out the change in momentum. That's this idea. Well, it's both of these ideas. A terrible job circling. It's both of these ideas. So yeah, we can figure out the initial momentum, the final momentum, use that to get J, the impulse, and then we're going to connect that with this idea. J equals Ft. Because now if we know the impulse, and I'm giving you the time, 0.025 seconds, we can figure out the force. So I'll tell you what, just to make it clear what's going on here, there is one pitfall here I'm a little worried about. Let's actually make a sketch of this. So I'll make two sketches. I'll make an initial sketch and a final sketch. So let's assume initially bumping the ball in volleyball, that's when you hold your hands out like this in front of you and you bounce the ball. So let's say initially, right before the ball hits your arms, let's say it's coming straight down. So V initial is 3.80 meters per second. And actually, all over the place. If it's going down, let's say, first of all, let me make these speed lines better. Let's make it negative 3.80 meters per second. So that's your initial drawing. Your final drawing, ground, you, there are your arms. The final drawing is you have bumped the ball in the opposite direction. So now the ball is going up. So we're going to say V final is equal to 2.40 meters per second. So a key idea here is even though the way I wrote these two speeds, 3.8 meters per second and 2.40 meters per second, they're both positive numbers the way that I wrote them. You need to catch this idea, though. They're going in the opposite direction, initially to finally. So they need to have opposite signs. So I pictured it this way, starting down and then, with a negative velocity and then going back up with a positive velocity. But that's, the key idea. So let's see. Different ways we can do this. Let's start with this. J equals P final minus P initial. And the other thing is, we know about J, is J equals Ft. Okay, so then by looking at these two ideas, hopefully you can see, I'll write it like this. Seems a little bit silly, but J equals J. So that means P final minus P initial is equal to, well, J is also equal to Ft. All right, if we're trying to solve this for F, what we want to do is divide both sides by T. So now T is going to go away, and we're going to end up with F is equal to P final minus P initial, all of this over T. Okay, and what is P final equal to? Well, P is mv. So P final is really mv final minus P initial is mv initial. And all of this over T. So at this point, again, I want F. I know all of these numbers. I know M, V final, still know M, V initial, and I know T. So I just got to put in the numbers. So F is equal to, I mean, I could factor out the M. That might save me a little bit of calculator work, but not enough to make it worthwhile doing. That's mass times V final is 2.40 meters per second, and it's up. 2.40 meters per second minus M, 0.240 kilograms. Okay, here's a little thing you need to catch. V initial. So remember, V initial is negative 3.80 meters per second. So yeah, positive times positive minus positive times negative. We're going to end up, this is going to end up adding a positive term, is what that's going to be. And then all of this divided by T. And T is that number, 0.0250 seconds. All right. Something to be aware of. There's an order of operations thing here. One way to fix it, put a big parentheses around the whole numerator. Now, if you do this in the calculator, 0.240 times 2.40 minus 0.240 times negative 3.80. You've got to get that part right. If I hit enter, I have 1.488, and then I want to divide this by 0.0250. And if I do that, I get 59.52. So F is equal to 59.52. It's a force, so it's going to be newtons. And if I'm keeping 3 sig figs, 59.5 newtons. Put a box around it. We solved for what we wanted. Force, units of newtons. That's all good. 59.5 newtons, that's a reasonable amount of force to put on a volleyball. So we're happy. So hopefully you found that helpful.